Hey guys, we're going to do notes over headings and bearings. So before I start going through all this, I kind of want to give you a definition of what these are. If you're doing surveying or if you're doing navigation, like you're flying a plane or navigating a boat, the directions are generally given in terms of bearings, and a bearing measures the acute angle a path or line of sight makes with a fixed north-south line. So for example, we might say, if you read this left to right, it just says south 35 degrees east, but if we were actually going to read it, we would say 35 degrees east of south. That's a lot of times how they will give you a bearing. In air navigation, bearings are measured in degrees clockwise from north. A heading is the direction an aircraft is pointing. So when we're measuring direction, we're always going to start from north. So if you think about your north and south, west and east, you always want to go from north in a clockwise direction. Kind of like how you would read a compass. And we'll always go clockwise to make it a positive angle. So it's a little different than how we were doing angles previously, where we made the positive x-axis our starting point. Now our starting point is the north axis when we're talking about headings. So in this first example, we have a plane that's flying on a heading of 120 degrees. And he's doing that at a speed of 200 miles per hour for 2 hours. So that means that they've actually traveled, if you go 200 miles per hour for 2 hours, that means you've actually traveled 400 miles. So we've kind of drawn that in this picture down here. Right here is the north axis. We've traveled on a path of 120 degrees. So we go clockwise from the north axis 120 degrees. And then if you'll notice right here, they've marked that this is 400 miles. And that's because we've traveled 400 miles in 2 hours. All right, let's look at another example. Okay, on the next example, we have a ship that's traveling at a heading of 285 degrees at 50 miles per hour for 5 hours. So if you're going to go 50 miles per hour for 5 hours, you're going to travel 250 miles. So we're going to draw a diagram of that. This is our north axis. So from here, from that north axis, we're going to go in the clockwise direction to 285 degrees. So this is the actual path that we're traveling. So this right here is our actual path. And we're going to mark on here that we've traveled 250 miles. Okay, on the next example, so a lot of times we're not going to have this compass already drawn for you. You're going to have to think about what it is on your own. And we'll give you a problem like this where we have an airplane is traveling on a heading of 200 degrees at 300 miles per hour for 5 hours. So that means if you do 300 times 5, you've actually traveled 1,500 miles. Okay, I'm going to go ahead and draw the north, east, south, and west on here. And I want you to think about the fact that, right here, this is, where we start at the north axis. This is 90 degrees later. If you go in the clockwise direction, this is 180 degrees. This is 270 degrees. And then a full circle makes it 360 degrees. So if you go 200 degrees in the clockwise direction from the north axis, you're going to end up about right here. So this is the path of the airplane. And then you're going to travel 1,500 miles. So we'll just label that line with 1,500. So that's how we would work that problem. Okay, sometimes navigation problems use the compass direction to describe an angle, and all the angles are going to be acute when they do it that way, and it's always measured from north or south, and so they'll write it like this. So like in this problem, we have John drove 30 degrees west of north for 100 miles. So first you find your north axis, and you want to go in the west direction from the north axis. So in this picture here, from the north axis, we go 30 degrees in the direction towards the west. So this right here represents our actual path that we took. Now, if we had done it the other way, that would have ended up being 330 degrees. So 330 degrees from just plain old north is the same thing as 30 degrees west of north. And then we could label this with 100 to show that that's how far we traveled. So Sorry, I don't know why that is showing on there. Okay, on the next example, we have Sarah who's going to swim 20 miles, and she's going to go 60 degrees east of south. So we're going to find the south axis first, and we're going to go in the east direction 60 degrees. So from here, we're going to go in the east direction 60 degrees. So this right here represents her actual path where she's swimming, and she's going to do that for 20 miles. So I'm going to label that there. Okay, on the next example, I'm going to need to move this up a little bit. Okay, on the next example, we have Azim walks 75 degrees west of south for 5 miles. So I'm going to draw kind of a dashed line to represent my north-south axis. We're going to go from the south axis, we're going to head in the west direction. So that makes me go this way. So his actual path will be right here, and he's going to do that for 5 miles. Okay, on the next example. Okay, on the next example, we're going to be, we're like an airplane that's going to start off going in a certain direction, and then we change directions sometime during the flight. So here we have an airplane that flies for 500 miles on a heading of 60 degrees. So this time it's just a plain old heading. That means that we're starting from the north axis right here, and then we're going to go clockwise 60 degrees. So this is our path for a little bit. And then after 500 miles, we're going to change directions. So again, we're using our north-south axis right here. And then from here, we're changing directions, and we're going to fly 200 miles on a heading of 150 degrees. So from the north axis, we go in a clockwise direction, 150 degrees. And this is our new path right here. So a lot of times, of course, we're not going to have these big circles drawn on your paper. You're going to have to think through that. So you're going to be drawing your north-south axis from the start. You're going to make sure, when you first read it, that you see you're going 500 miles on a heading of 60 degrees. So from the north axis, you go 60 degrees this way. So this would be your path. And you're going to, ooh, I did that so bad. Sorry, I went way over 60 degrees. Let me erase that. Sorry about that. Sometimes it helps to go ahead and draw the whole compass, but from here you're going to go 60 degrees. So this is our 500 right there. And then once you get to your stopping point, you're going to draw another axis. And so from here, you're going to go 150 degrees. That was the one I was trying to draw a while ago. So from here, I go past the 90 degrees, about 60 degrees past that. So this will be my 200 degrees. And then 200 miles at that 150 degrees. A lot of times what we're going to be doing on the next lesson is we're going to be making a triangle, and we'll use that to figure out different things. So let's do the next example. So using that previous problem, we want to find the angle that's between the two flight paths. So he started off flying in this direction right here, and then he ended up changing directions, and now he's going this way. So what we're trying to figure out is this angle that's between the two flight paths. Well, if you'll remember from geometry, this right here is the north-south axis, and this right here is your new north-south axis whenever you change directions. Those are parallel lines. And this first flight path right here represents a transversal that goes through those. And so if you'll recall, alternate interior angles are congruent with each other. So this angle that's right here and this angle right here will be congruent with each other. So this part of it, that angle is, this part right here is 60 degrees. So this part right here will also be 60. But then you've got a little bit extra right over here that we need to figure out. And if you'll notice, this is from 180 to 150. So that's another 30 degrees, which makes that angle between those two, that's going to be 90 degrees. So basically you had this one was 60, and then this other alternate interior angle was 60, but you had a little bit over here that was 30. So this angle between those two ended up being 90 degrees. So 60 plus the 30 is 90 degrees. Okay, let's do another example. Okay, on this next example, we have a plane that's flying for 3 hours at a speed of 200 miles per hour on a heading of 120 degrees. So he has actually flown 3 times 200. He's actually flown 600 miles on that heading. So let's draw that real quick. We've got our north and south axis. I'm going to also draw the other, just so I don't screw up. You remember how this right here represents 90 from the north axis. So 120 will be another 30 degrees past that. So right here, this is 90. This is another 30 degrees to get that 120 right there. Okay, so after he has flown 600 miles, he then just has to change directions. So now we're going to draw another north and south axis, west and east. And now we're going to go for 2 hours at 250 miles per hour. So that means that we're going to fly another 500 miles. Okay, on a heading of 20 degrees. So from the north axis here, we're going to go 20 degrees. So that's about right here. That's 20 degrees right there. And we're going to go 500 miles in that direction. And then this is asking me to draw a diagram, which we have to represent this situation, and then find the angle between the two flight paths. So we're looking for this angle right here. Well, if you'll notice, let me change pen colors. We've got this 90 and we've got this 30, and we've got this whole line right here. So this will be another 60 degrees right here to make that whole 180 degrees. And then recall that this line and this line are parallel lines, and so this is a transversal going through those parallel lines, and so alternate interior angles are going to be congruent. So this angle right here will also be 60 degrees to match this 60 degree angle. So the angle between those two flight paths is the 60 plus the 20, and it's going to be 80 degrees. Those two angles add up to be the 80 degrees. Okay, let's do some practice problems. Okay, these problems are just wanting you to draw the following bearings. Remembering a bearing is whenever we tell you what direction from either the north or south we're going. They're always going to be acute angles. So this time they want us to go 50 degrees west of north. So here's the north and here's the west. So we'll start here and we're going to go in the west direction 50 degrees from the north. So this angle right here is the 50 degrees. On the next one, we're going to go 40 degrees east of south. So here's south, here's east. So we're going to go 40 degrees from the south axis, 40 degrees. So this is 40. On the next one, we want to go 30 degrees west of south. So here's the west axis, here's the south. And we're going to go 30 degrees from the south to get that line. On the next one, we're going to go 20 degrees east of north. So here's north, this is east, and we're going to go 20 degrees from the north axis for our actual path. Okay, for these, we're drawing headings. And remember, headings always go from the north and they go clockwise. So here's my north axis. I'm going to go clockwise 50 degrees. So this would represent the path that I'm taking. This is the 50 degree angle here. Okay, now we're going to go 250 degrees. So again, from the north, we're going to go in the clockwise direction. This would be 90, this would be 180, this would be 270. So if I'm going to go 250 degrees, it will end up right here, about right there. On the next one, we're going to go 310 degrees from the north axis clockwise. If this is 270 and this is 360, when we go 310 degrees, we're going to end up about right here. Okay, on the next one, we have 130. Again, this is 90, this is 180. So if we go from the north axis clockwise 130, we'll end up right there. So you'll need to think of some things like this part of that 130 is 90, and this part would be 40, and then this part here would be 50. So occasionally when you're doing a combination of flight paths, you might have to think about how that angle has been broken up. Let's do another example with a ship. Okay, on this one we have a ship traveling at a speed of 20 miles per hour for 3 hours. So that's 60 miles. And that's on a heading of 200 degrees. So here's my north-south west and east axis. So I'm going to go on a heading of 200 degrees. This right here would be 180 from the north axis. So I'm going to go another 20 degrees past that. So this would be 20 degrees if we to get that full 200. We went 180 plus another 20. And then it's going to change directions and travel at a speed of 30 miles per hour for 2 hours. So another 60 miles. I should mark this as 60. I'm going to mark that with a different color. So this is 60. Okay, so from here, I'm going to draw another axis. And I'm going to go from its north axis right here. We go a full circle around until we're about 30 degrees shy of the full 360 degrees. If we're going to do 330, we're 30 degrees short of a full 360. And then this is also going to be 60 degrees, or I'm sorry, 60 miles. Okay, and so this is asking me to draw a diagram of the situation and find the angle between the two paths. So this is the angle right here that we're looking for. And if you'll recall, we've got alternate interior angles that are going to be congruent. So we've got this parallel line right here, this parallel line right here. This angle that's 20 degrees will be the same as this angle right here because those are alternate interior angles. So this angle right here will be 20. So the angle between them will be 30 plus 20, which equals 50 degrees. All right, one more problem. Okay, on this problem we have a surveyor gives the following description of a plot of land from a granite post. So we've got a post right here. We're going to proceed 195 feet east along Tasker Hill Road. So we're going to go 195 feet this way. And then along a bearing of 32 degrees east of south. So I'm going to draw my little axis here, and this is still my north, south, east, and west axis. And we're going to go from the south 32 degrees in the east direction. So that'll put me this way, where this is 32 right here, east of south. And we're going to go for 260. So I'm going to try to make that a little bit longer, 260 feet. Then along a bearing of 68 degrees west of south. So again, draw myself a new axis. And I'm going to go in the west direction 68 degrees from the south axis. So this right here will be 68. And we're going to do that for 385. Oops. And then we're going to head due west back to the point south of the granite post. So I'm going to go this way until I'm south of that granite post right there. And finally along a line back to the starting point. So it wants us to draw a diagram of the plot of land and give all 5 angles. So I know this is a right angle because this was going west and this is going back up to that post, which was directly north of that. So that has to be a right angle. This will also be a right angle because these east-west lines right here have to be parallel, which makes those same side interior angles supplementary. This angle right here is 90 degrees. So when you combine those two, you get 122 degrees. Let's see here. We got that let me show you with the highlighter. This line and this line, those are parallel lines. And so this is an alternate interior angle with this right here, which makes this angle 32 degrees. And for you to get this, this is a full straight line right there, so 180 degrees. And you've got that 32 and that 68, the 32 and the 68. So subtract those from 180, you'll get that this angle right here has to be 80 degrees. And then you've got yourself another set of axis right here. This 68 degree angle will be the same as this angle right here because those are alternate interior angles. This would be a right angle, so this angle is 158 degrees. So those are the 5 angles that make up this figure. All right, that's our notes for today. Thanks, y'all.